we're going to be looking at experiments. As we go through the section, have your handouts open in front of you and fill in any of the gaps as you go with the information in this presentation. What you need to be able to do by the end of this presentation is to be able to identify different types of experiment, to identify and explain the advantages and disadvantages of the different types of experiment, to identify and explain validity issues and how they can be overcome, identify and explain reliability issues and explain how these can be overcome, identify and explain ethical issues in experiments and say how these can be overcome, and finally, to be able to apply this knowledge to a stimulus piece of research. So, experiments. All experiments have an IV, an independent variable, which the researcher manipulates. They have a DV, a dependent variable, which the researcher measures, and extraneous variables which the researcher controls. Now, extraneous variables are all of the variables outside of the IV that can confound or mess up the results of the experiment if they're not controlled. So these can be things like time of day that the participants are tested, weather, the light levels in the room. Any of these things could affect the participants' performance on the DV, therefore we need to control them. If we've done that, then we can draw cause and effect conclusions. The IV represents the cause and the DV represents the effect. The simplest structure of experiment generally has two conditions. Firstly, an experimental condition in which participants are exposed to the IV. Secondly, a control condition in which the participants are not exposed to the IV. Then, at the end of the experiment, the performance in the two conditions is compared. If there's a difference in the DV between the two groups, then it must have been the IV that caused it. Because if all the extraneous variables have been controlled, then it means that the IV was the single only difference between the two conditions, and therefore the IV must have caused the DV. This is the cause and effect conclusion. There are different types of experiment, three main types. Firstly, there's a lab experiment. Now this is conducted in a controlled environment, usually a psychology laboratory. Secondly, a field experiment, which is conducted in a real-life environment. Here, for example, we can see that it's conducted in a train. It could be conducted in a classroom, it could be conducted on the street. Any of these are a field environment because they're real-life situations. The third type of experiment we get is called a natural experiment. This is also called a quasi-experiment. Now, quasi or natural experiments have a naturally occurring IV. So, for example, we can see in the images here, if a researcher was interested in looking at the difference in response to TV programs between blondes and brunettes, that would be a natural experiment, because the researcher in a natural experiment has no control over which participants go in which conditions. In lab experiments, and sometimes in field, the researcher can decide who goes in which condition. We can randomly allocate participants to conditions, and this gives us control. In a natural or quasi-experiment, this isn't possible. Nature has already decided the brunettes are going in the brunette condition and the blondes are going in the blonde condition. We've got no control over that. The other example you can see here would be looking at the difference in cultures, in people from different cultures and their response to something. Again, we as researchers can't decide who goes in the Western culture condition and who goes in the non-Western culture condition. Nature has decided that, so we just have to accept the groups as they naturally occur. This is what we mean by a natural or quasi experiment. Now, natural or quasi experiments can be conducted in either a lab or in the field. It really depends what we want to do. For example, we could look at the difference between genders. If we wanted to see the difference between males and females in their response to something, we could conduct that in a lab under quite controlled conditions. If we were looking at the effects of anything else, we could do it in a field, in a natural environment. Let's focus on lab experiments. As we said, lab experiments are conducted in a controlled lab environment. We can see 3 different examples here. In a lab environment, we can use a lot of specific materials and technologies, as we can see in the bottom left-hand image here. We can see on the top left, this is a still from Milgram's research, which was conducted in controlled conditions. Now, the strength of conducting experiments in a lab condition is firstly that we have maximum control over the EVs or CVs, and this gives us really high internal validity, and therefore we get valid cause and effect conclusions. The weakness, however, is that because of the unnatural environment and tasks, this leads to reduced ecological validity, and therefore we can't apply the findings to real life. If you look in your handout, you'll see we've got an example of a lab experiment. So, many parents believe that music impairs students' ability as it decreases concentration. If we compared the test mark score of those students who completed it under exam conditions while listening to music with those who completed it without music but under exactly the same conditions, would this be a reliable comparison? Well, the answer here is yes, it is reliable because all the extraneous variables have been controlled. Okay, let's move on to field experiments. We can see here some examples of different sorts of real-life environments in which psychologists can conduct field experiments. Now, there are different strengths and weaknesses to field experiments. Let's look at a strength. One of the greatest strengths of natural experiments is that because they're conducted in a natural environment, we tend to get natural behaviour. This gives us high ecological validity, and this is a strength because it means we can generalise findings to real life. But the biggest weakness is that because it's conducted in a natural environment, it means we have limited control over the EVs or CVs. And this leads to reduced internal validity in the experiment, so it means we have invalid cause and effect conclusions. Again, if you look at your handout here, you can see that we've got an example of a field experiment. Pilyavin et al. In 1969 conducted a classic field experiment in social psychology. They wanted to observe whether people would help others under certain conditions. The researcher arranged for a Confederate to collapse in a New York subway. We can see an example of something like this on the top right, the subway. In one condition, the Confederate appeared drunk and carrying a bottle of alcohol, whilst in another condition, the Confederate appeared old and frail and carried a black cane. Pilyavin found people helped more when the Confederate appeared old rather than drunk. So in this field experiment, the IV here was the characteristics of the collapsed person. This was what the researcher was manipulating. And the DV was the help that was given by the passers-by, because this was what the researcher was measuring. Natural or quasi-experiments have different strengths and weaknesses again. We can see examples here of the natural or quasi-experiments. The greatest advantage of natural or quasi-experiments is that sometimes we simply can't manipulate an IV for ethical reasons. So for example, if we look at the bottom left picture, we can't manipulate the gender of children. Well, theoretically we could put them in lab conditions from the time they were born. We could inject them with hormones to lead them to show the characteristics of a different gender, and then we could measure their performance on different things because we'd controlled their gender by hormone injections. However, this is clearly hideously unethical, so sometimes we have to accept that we can't do this. This is where natural experiments come in. We take the gender that nature has dictated people have, and this then enables us to draw cause and effect conclusions. We take males and females and we just look at their performance on different tasks. One of the greatest weaknesses, however, of natural or quasi-experiments is that we often have a great lack of control over the EVs or CVs. And this leads to reduced internal validity. So again, our cause and effect conclusions tend to have very reduced validity. If we look at the example in the handout, a researcher is interested in finding out how effective reading schemes are for 5-year-old children. He simply finds a school that is currently using the old reading scheme and a school that has decided to change to the new modern reading scheme. The researcher plans to examine the effect of this on the children's reading scores at the end of the year. Remember, the researcher is not manipulating the reading schemes in any way, nor do they have any control over how it's delivered. They're simply observing the effect. So, as we said, we have real problems over control with natural or quasi-experiments, so our cause and effect conclusions have reduced validity. This leads us directly into validity and experiments. Validity means accuracy, so it refers to the accuracy of the cause and effect conclusions that we draw. There are two main types of validity in experiments. Firstly, internal or experimental validity, and secondly, external or ecological validity. Now we're going to look at each of these in more detail and look at where there are problems with them and how we can control them. But at the moment, you just need to know threats to validity and ways of ensuring or dealing with validity. So focus on this on the next couple of slides. Internal or experimental validity is the extent to which the observed effect, the change in the DV, is due to the experimental manipulation of the IV rather than extraneous variables. Now, there are several threats to validity in lab experiments. Problems with a task often create problems with drawing cause and effect conclusions. The environmental conditions, so temperature, time of day, noise, all of these can affect performance on the DV and therefore again cause problems with the cause and effect conclusions that we draw. Other uncontrolled CVs. Demand characteristics, with the participants looking for clues about what the researcher is expecting and then trying to perform in line with that or trying to go against it. And finally, experimenter effects, whereby the experimenter is unconsciously giving clues or cues to the participants about what they should do. Okay, so read the example in the handout. A psychologist has done a field experiment to see the effect that regular exercise has on stress. They use a self-selected volunteer sample. The mean stress level was calculated for the exercise condition and the no exercise condition. Now here, if we look at the threats to validity in this particular case, we can see that one big threat may be that participants might lie about having completed the exercise because this is done in a natural environment. So it's a field experiment. So we've got very little control over whether they do it. Now this could really cause problems to the cause and effect conclusions. It threatens the internal validity of the study. If we look at the second experiment, a psychologist has done a natural experiment to test the effectiveness of an old and new reading scheme on 5-year-olds' reading ability. They use opportunity sampling and take advantage of one school that is continuing to use the old scheme and one school that's trying out the new reading scheme. So this, as it says, is a natural experiment. Now again here, problems with validity may be caused by the fact that these two schools may be in completely different areas. Different socioeconomic areas have different incomes, and it may well be that in one of the schools the children's parents are very supportive and encouraging and can provide private tuition. In the other school, their parents may be less encouraging and supportive and may not be able to provide additional tuition. Therefore, this could affect the DV. This could affect the student's reading ability. So if we're trying to draw a cause and effect conclusion that it's the reading scheme that affected their reading ability, we could be completely wrong. It could be the private tuition that they've had. This is the big problem with natural experiments, that we simply don't have the control over the CVs. Okay, so how do we ensure validity? The main way is that we use standardized procedures and instructions throughout the experiment in both conditions. If we use these, then we tend to be able to control things much more carefully and we increase the validity. Validity means accuracy, and there are two main types of validity that relate to experiments: internal or experimental validity and external or ecological validity. Internal or experimental validity is the extent to which the observed effect, the change in the DV, is due to the experimental manipulation of the IV rather than due to extraneous variables. There are several specific threats to internal validity with experiments. Firstly, problems with the task. If the task isn't conducted in exactly the same way in the two conditions, then any difference in performance between the two groups may have been due not to the IV that we're manipulating, but due to the differences in the way the task has been performed. The environmental conditions, if they differ between the two groups, again could cause a change in the DV. So different lighting levels in the two groups, different sound levels in the two groups, either of these could affect performance. Any other uncontrolled CVs. So for example, if something happened before the participants went into the experiment in one condition, this might affect their performance, and it would be this that causes the change in the DV, not the IV. Demand characteristics will also affect internal validity when participants are trying to guess what the hypothesis is and look for clues or cues and then change their behaviour accordingly. Experimenter effects. In the same way that the participants are looking for clues, the experimenter can often unconsciously give clues or cues as to what they're expecting in the two conditions. Again, this then influences the participants' performance. So our DV is as a result of the experimenter's behaviour, not the IV as we wanted. Ways to ensure validity in experiments is to standardise procedure and instructions. This ensures internal validity. So if the task is identical in the two conditions, it's carried out in an identical way for an identical time in both conditions, and the instructions are identical for both conditions, ideally presented either on a screen or on paper. That way there can be no experimenter effects causing changes in motivation levels or understanding levels between the two conditions. If we have a look at the handbook, we can see that there are two experiments here. So let's have a look at the first example experiment. A psychologist has done a field experiment to see the effect that regular exercise has on stress levels. They use a self-selected volunteer sample. The mean stress level was calculated for the exercise condition and the no exercise condition. What might be one internal validity problem with this experiment? Well, if we look at it, this is a field experiment, so we don't have that much control. So here it might be, for example, that there are problems with the task, that we can't control the task properly. One group of participants may have performed one set of exercises, the other group may have performed different exercises. All the participants may have performed them for different amounts of time. Now, because of this, it makes it very difficult to assume that it's this that has caused an effect in their stress levels at the end, because there's been no control over the way that task has been performed. If we look at the second experiment, a psychologist has done a natural experiment to test the effectiveness of a new and old reading scheme on 5-year-olds' reading ability. They use opportunity sampling and take advantage of one school that is continuing to use the old scheme and one school that is trying out the new reading scheme. In this experiment, this natural experiment, we have very little control over the sample that's been used here, because we have to simply take whatever school is using the new reading scheme. Now, in this particular case, it may well be that one of the schools was from an affluent area where parents are supportive and encouraging of their children and read with them a lot at home. In the other condition, it may be in a poorer area, so parents may not be as supportive, not be as encouraging, and not read with their children as much at home. Perhaps they don't have as much time to. So it may well be that it's the difference in the parents' support of the children that is causing the effect in their reading ability, not the reading scheme as we're interested in. Moving on to external or ecological validity. Ecological validity means the extent to which we can generalise the results from the set of environmental conditions of the lab to other environmental, mainly real-life conditions. There are several threats to the ecological validity of experiments. Firstly, the false environment of a lab. Because it's such an unnatural environment, it can be very difficult to assume that behaviour will be the same in real life as it is under these artificial conditions of the laboratory environment. Secondly, poor mundane realism of the task. Often the tasks that we set participants in the lab environment can lack realism. They aren't the same as we would do in real life. So perhaps if we're testing students, for example, in a lab environment, we might give them a list of words to learn to test memory. Now, in their everyday revision for their studies, they wouldn't have to learn a list of words. In psychology A level, you don't have to learn a list of words. You need to learn material in a very different way to that. So it can be difficult to generalise from the findings there to the findings in real life. There are ways to ensure ecological validity. The best way to do it is to replicate using a different environment. So if we carried out this study on students in a laboratory environment on memory, we could then do an experiment in a real life setting with different materials, more realistic materials. And we can see this here in tasks. If we get the same results when we test in a different environment and we test using different tasks, we can assume that the results do have ecological validity. Reliability in experiments. Reliability means how consistently a method measures over time when it's repeated. Methods of measurement should give similar scores when repeated on the same people under similar conditions. For example, a ruler gives the same measurement of length each time it's used to measure an A4 sheet. Reliability in experiments can be threatened in several ways. One threat is inconsistency in our measuring tools. So if we're not measuring people in exactly the same way, using exactly the same system, this can lead to problems in the reliability of our findings. We can get inconsistency on the part of the experimenter. So the experimenter can influence things in different ways, they can interpret things in different ways, and this then compromises the reliability. We can also get inconsistency on the part of the participants, where the participants don't perform the same at different times. In order to ensure reliability, there's one main method that we tend to use. This is known as the test-retest method. This involves completing the experiment once and then again 1 week later, or perhaps a month later or 6 months later, using the same participants and comparing the scores. If they're similar on the first and the second test, then we say that the test is reliable. So let's go back to the handout and look at the two experiments that we looked at earlier. So we've got the field experiment looking at the effect of regular exercise on stress levels. In this experiment, one thing that may have compromised the reliability may be that the participants' stress has been measured differently in the two conditions. If this is the case, then that experiment lacks reliability. In the second experiment, the natural experiment, looking at the old and new reading scheme and its effect on children's reading ability. If different researchers have been used here, if a number of experimenters have been used, then they may have interpreted the children's reading ability differently. They may have interpreted their words differently, and therefore the experimenters aren't behaving consistently. They're not measuring consistently. That then compromises the reliability of this study. Finally, ethics. Now, there are no general ethical issues that apply to all experiments. What we need to do is to look at the experiment in question, whether that's a lab, a field, or a natural experiment. Consider what's being done to the participants, with the participants, and how it's being done. However, field experiments can have a lack of informed consent and a lack of right to withdraw if participants don't know they're being experimented on. Now, this can happen more often in field experiments because participants can be experimented on without their knowledge, potentially. Obviously, this can be an issue in lab experiments as well. It's more difficult to get participants into a lab without them realising that they're taking part in an experiment. So they know they're taking part in it, but we can have the lack of informed consent and the lack of right to withdraw if we don't tell them what the specific aims of that lab experiment are. But generally speaking, we might see it possibly more often in field experiments. But the golden rule with ethics is look at the specific experiment that's being done, look at what's being done with the participants, to the participants, and consider the ethics on an individual basis. Finally, exam questions. Use the usual formula, SEX, but add an D to answer the question. So, S, state what the validity or reliability or ethical issue is. E, explain the effect this may have had. X, give examples of keywords from the study to hook it in directly or to link it directly to the study. And finally, D, explain how you would deal with this issue with detailed specific examples from the study again. So make sure when you do the D element, how you would deal with it, that you do SEX again. State how you would deal with it, explain what this involves, and give examples of keywords from the study to link it directly in. And that's it. That's the module on experiments. So hopefully you now understand it and you can do the past paper questions with confidence.